In order to understand how the PKS enumerator works, we need to visualize all these different colored functional groups as separate building blocks. So when we were selecting the building blocks or structural motifs for the PKS enumerator, we looked at 18 experimentally confirmed bioactive macrolides. So what you're seeing here are all the macrolide antibiotics that we studied. So you can see some of the famous ones like erythromycin, azithromycin, clarithromycin, etc. For example, SM002, which is a methyl structural motif, is found and extracted from all 18 bioactive macrolides that we studied. And what we did next, we divided the structural motifs into two different categories, common and rare, based on how frequently they were observed on those bioactive macrolide scaffolds. For example, if it is found in at least 5 among those 18 bioactive macrolides, we put them in the common bin. If it is found in less than 5, then we put them in the rare category. This one is to show the distribution of the common structural motifs found in 18 bioactive macrolide scaffolds. The second column here is showing in how many macrolide scaffolds that they were observed in, and the third column is showing the occurrences per macrolide scaffold. For example, the very first one, SM001, is found to repeat up to 1 to 3 times per macrolide scaffold. So, how does it work actually? So in order to make it work, you need 3 major inputs. You need to specify the common and rare structural motifs, and you need to specify a bunch of building rules. So once you have specified the building blocks, it loads them into the software, and at the core it does 2 main things. So first, what it does is it adds them one by one and creates a macrocyclic template. And the second thing it does is it permutes them. So it's in a mathematical sense of permutation. So if you have 3 different building blocks, you can create 6 different permutations where the position of those building blocks matters. Essentially, it's the same idea. We are permuting all the building blocks that you have selected based on the building rules, and we create all possible arrangements of building blocks. And as the output, you have several files if you want to. You can also choose to output which files you want. For example, you can choose to output them in SMILES or SDF file. SDF file will give you 3D confirmation of your structures, and also CSV files where it is easier for you to do data analysis. And the green ones are the files that contain information about your library. I'm going to show you in the next one. So here is just to show an example of what the output files look like. So this is the SDF file. You can actually rotate the structures in the 3D space, and we have computed a few some key important molecular properties which are normally used to assess drug likeness and oral bioavailability. This is the library info file that compiles a bunch of building rules that you have previously specified. It even tells you the direction in which the building blocks are being permuted, and also tells you how much time it takes to enumerate those libraries. This example files that you're actually seeing here is taken from a library that sample library that we generated, which contains 1 million macrolide scaffolds by skipping 10K molecules at a time. I'm going to explain a little bit about what I meant by that. So the next file that it produces is called SM-info file. It tells you distributions of all the structural motifs and their occurrences per macrolide scaffold. So you know exactly what your library is made of and how often each structural motif has occurred in the entire library or in each macrolide scaffold as well. So here is the graphical user interface GUI of the PKS enumerator, and you can see 2 major categories, common and rare structural motifs, and the yellow boxes that just pop up here, this is the parameter that you can control to specify how often you want each structural motif to be repeated per macrolide scaffold. For example, look at SM002. which has associations with number 4. So here you are specifying that you want that particular structure motif SM002 to repeat maximally up to 4 times per macrolide scaffold. So let's look at the building rules for now. So here is a range of command and ray and total structure motifs that you can manipulate per macrolide scaffold. So essentially, the very first one, you are saying that you allow macrocycles with 12 to 16 at most common structure motifs per macrolide scaffold, and then you can also manipulate the range of ray structure motifs, and also you can control the ring size, which is the equivalent of total structure motifs. So essentially, you're allowing, in this example, you're allowing ring sizes that has 12 structure motifs in each macrolide scaffold. So the next section is where you can control your library in general. So the first one is the number of permutation to skips. Here it's saying a number of 100k. So this is a little bit harder to explain, so I'm going to show you a pop-up video to explain this concept. So the way that it works is it generates the very first macrocyclic template, and then it permutes all possible arrangements, right? So it samples the very first one, and then it skips a number of permutations. So you are manipulating the number of permutations that you want to skip, and then it looks at the next compound, and then it skips again. So it's jumping over a subset of population. So essentially, you're controlling how many permutations you want to skip after every sampled macrocyclic scaffold. So this parameter is kind of also allowing you to manipulate the diversity of the library. So if you set a higher number, then you can skip a higher level. You can have a higher level of diversity in your library. The next one is the library size. Here the example is just you can generate 1 million, or how much size you want. It's up to you. And you can choose to add an additional answer to each macrocycle, making them macrolide scaffold. And you can also output them as either CSV or SDF files. So in the current version, we have included an option for skipping the 3D generation, and you can just generate smiles, which makes it a lot faster. Here is the second version that we have already developed. We're going to be releasing it soon. So here you can manipulate the molecular properties or descriptors of the macrolide scaffolds as well. So here are a bunch of molecular properties that are currently included. So you can specify a range for each of them, and if you do that, only the scaffolds with those molecular properties will be generated. So essentially, you are fine-tuning your library further by controlling the chemical properties.